Welcome to EDU World Space.
We're asked to find the moment about D to B, given that the force from C to F is 33 newtons. And I went ahead and found these position vectors of the different locations on the given figure. So I'm going to write out the formula that's going to help us solve this problem. So the moment from D to B, that's going to be equal to the unit vector of D to B times the dot product of the DC vector cross the force vector of CF. So I'm going to find this expression first, the unit vector of dB. So we're going to first find the dB vector, and that's going to be equal to the B vector minus E vector, and that will give us a vector of 1.2i minus 0.35j. And now we can find the unit vector by taking the dB vector and dividing by its magnitude. And that will give us a unit vector of 0.96i minus 0.28j. And next we're going to find the DC vector. So to find DC vector, we can do C vector minus D vector, and that will give us a vector of 0.2j minus 0.4k. And lastly, we're going to find this term. So to find that term, we need to first find the CF vector. So the CF vector, it's going to be equal to the force, or the F vector, minus the C vector. And that's going to be equal to 0.6i minus 0.9j minus 0.2k. And now to find the force vector of CF, we take the magnitude of the force, which was 33, and then multiply it by the CF vector, and divide it by its magnitude. And this will give us a force vector of 18i minus 27j minus 6k. And we now have our terms to plug into this equation. So we now have the moment about dB is equal to our unit vector dot the DC vector cross the force vector. And we can write this expression as the determinant of a matrix. So we can write this as the unit vector in the top row, the DC vector in the middle row, and the force vector in the bottom row. And solving this matrix, we will get a final answer of -9.504 Newton meters.